Okay, so I couldn't leave you guys with just that. So we left off at -2/1, which is -2 as our unit rate. So we can actually see that show up in the equation right here. -2 as our unit rate is showing up right there in front of the x. So hopefully you're noticing that little pattern that's been happening. And then our initial value, 14, is right there. It's that other number that makes this not proportional. That's what makes this not start at 0, 0. Okay, so if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 is right there. There's 14. So this one is starting way up here at 14, and then it goes down to 12. Down to 12 for every 1 for the x. Down 2 more for every 1 for the x. Down 2 more for every 1 for the x. And so that's going to be our constant rate that's making this line look like it goes straight down that way. And so that's what our points would look like if we graphed them. And I wanted you to see that this unit rate does show up in the equation right there by the x. And our initial value is our starting point, or the point that we added on that we already had. All right, and then I wanted to go through these last two examples, number 7 and 8. Write an equation for the following graph. All right, so we need to look at the ordered pairs that are here. So where x is 0, this graph hits the point right there at 6. All right, so that already tells me my initial value. My initial value is 6, or we could write it as 0, 6. That's our starting point. We start at 6. So we can already start writing an equation. Let's see, number of papers graded to number of hours. So after 0 hours, apparently I already have 6 papers graded. After 1 hour, I'm going to look up here. It looks like I have 12 papers graded. 12 papers right there. After 2 hours, I have 18 papers graded. After 3 hours, I have 24 papers graded. And after 4 hours, I have 30 papers graded. All right, so there's all of our little ordered pairs that match this graph. We can see the initial value pretty quickly, but let's look for the unit rate. Remember, our unit rate is how the y changes per every x. It's y per x, y for every x. So how is the y changing? Well, it looks like it's adding 6, so it's going up 6 for every 1 that it has for x. So if our unit rate is up 6 over 1, then that tells me the unit rate is 6. So that tells me this equation started at 6, and then I'm adding 6 more papers graded per every hour of grading. So it looks like it takes me quite a while to grade those 6 papers if it takes me an hour for 6 of them. So we can write it that way, or we can switch things around and write it y equals 6x plus our initial value of 6. So that's how we would do that one. Let's look at that again, number 8, and I promise this is our last one. Let's look at these values. So this one we look up here, and it looks like it starts at 0, 10,000. All right, what are they talking about here? Whatever it is, our initial value is 10,000 this time. So we're going to start at 10,000, and this is volume in gallons over time. So it looks like whatever's going on here, we've got a leak because these gallons are going down every hour. So it looks like we've got a leak, but we start at 10,000, and so let's say y equals 10,000, and then we have to figure out what's changing from there. So after 1 hour, it's kind of hard to tell. So notice they don't have the 1 hour here listed. Oh, they did give us letters T and V. So they don't have the 1 listed there. So V equals something to do with T. So this is V and this is T. Okay, it doesn't have 1 listed there because 1 is kind of hard to tell. It looks like it's in the middle, maybe 9,500, but since it's kind of hard to tell, we skip it. And it looks like after 2 hours, it's a little easier to tell. So after 2 hours, it's right there at 9,000. Okay, so then after 4 hours, it's at 8,000. I think I see this pattern. 6 hours is right there at 7,000. And 8 hours is right here at 6,000. Okay, good. The pattern I was thinking continued. All right, so what's going on here? Well, it looks like it's losing. it's subtracting 1,000 gallons. That's a lot to lose. So change in y over change in x is how we look at this. So it's losing 1,000 gallons every 2 hours. 1,000 gallons every 2 hours. So that's not quite the unit rate yet. We do need to divide that. So $1,000 every, or 1,000 gallons every 2 hours, we divide, and we get that it's losing 500 gallons every hour. For every 1 hour, it's losing 500. So yes, that was 9,500 right there. All right, so if it's losing, that means it's subtracting 500 gallons every hour. And it looks like they want hours to be capital T because that's how they've labeled it there. All right, so the other way to write this would be V equals negative 500T plus that initial value of 10,000 gallons. So that's how we would write the equation. So we always want to start with the ordered pairs, putting them in the table, and then look at our patterns. Change in y over change in x for the rate, and the initial value is where x equaled 0. So that was 0 and 10,000. Again, what we do first, so let's just write a quick note here. Number 1, look at ordered pairs. Number 2, find where x is 0. Find the initial value. Initial value. And the third thing we do, number 3, is look for the rate. Find the rate. There it is. Find the rate. And that's how the y is changing for every time the x changes. Change in y over change in x. All right, don't forget you do have an exit ticket to try, and then ask me at the table if you need help or if you just want me to check. See you soon.